Hi guys, this is Amar and welcome to Network Engineer Stuff. So guys, in this video, we'll focus on OSPF Chapter 2 area. So guys, in Chapter number 1, OSPF Introduction, we have taken enough understanding of OSPF basics. We have gone through the features of OSPF. So I call this features as OSPF superpowers. Any protocol, is super because of its features. Because those features are nothing but its superpowers. So OSPF also have this superpowers. What are the superpowers? What are the features of OSPF? We have seen is that each OSPF router have an end-to-end visibility of the entire network in form of topology table. So OSPF have something known as topology table, in which all the routes to reach all the networks is present. So it have end-to-end visibility of the entire network. In OSPF, the updates are triggered. If something goes down in the network, there's a topology change in the network, immediately, and you say triggered, we mean to say immediately that that update is been sent to all the routers in the OSPF domain. And this particular updates will have, of course, the critical SPF update or critical SPF information, I'll say. So since the updates are triggered, the convergence is pretty fast in OSPF. So these are the two powers or superpowers of OSPF, that is end-to-end visibility and the convergence is fast. Now this looks good, on paper. This OSPF features appears to be its strength and it must work perfectly, right? But guys, there's a twist in the story. Now this will work fine, this OSPF features, this end-to-end visibility and the fast convergence, everything will work fine if we have less number of routers in the OSPF domain. But let's say you have not 10 routers in OSPF domain, but you have 1000 routers in OSPF. Once we have 1000 routers in the network where OSPF is running, there will be an issue. I'll explain you what is the issue. So let's say this is router 1, this is a router 2, this is a router 3, let's say this is router 4, router 5, router 6, router 7 and so on till router 1000. So this is a network. Okay, OSPF is running in this. So this will be my OSPF domain, right? This will be OSPF domain. Now, let's say the link between R5 and R6 goes down. Now, when this link goes down, this will result into SPF calculation on all the 1000 routers. All these 1000 routers will do SPF calculation, because when this link goes down, this R5 is going to send the update to all the routers that the link between R5 and R6 has gone down. Okay, so this will be an SPF update which will be sent to all the routers, and all the routers will do SPF calculations. That is shortest path first calculations. So, right now, because this network is huge, we have 1000 routers. Each router will be handling one more, thousands of routers, hundreds of routers, means each router will be handling thousands of routes, right? So in such a big network, things are always changing. There's always some topology change. Some connection will be flapping, some device will be getting rebooted. Something is going to happen, every minute, every second, something is going to happen. So this will result that the SPF updates will be frequently. So there will be an issue of frequent SPF update, right? Now, because of this frequent SPF update, what will happen? Okay, so let's say this is a router in OSPF. Now it is getting frequently SPF updates. Now it will be always, its CPU will be always busy in doing that SPF update, right? So this will result into something known as high CPU utilization. utilization, and also it will result into high bandwidth utilization. Of course, the bandwidth, which is meant for data, which has been utilized by the SPF updates, frequent SPF updates. So this can result into these two issues, in which is not correct. So we can conclude that the biggest strength, this two strength of OSPF, that is end-to-end visibility and fast convergence. This strength, we can say that the strength can become the weakness of OSPF. So designing OSPF, guys, is so important. When we say designing OSPF, it is super important because of its features only. So we have seen this point, right? Frequent SPF update is a problem. So whenever we are running OSPF on a huge network where 100 or thousands of routers are present and each router is handling thousands of routes, okay, and in such a huge network, something is going to flap. There will be always some network topology change. That means each router in OSPF domain will be busy in processing frequent SPF update, and which will be resulting into high CPU and bandwidth utilization. So what will be the solution? Now, before understanding solution, I will try to explain you the problem and the solutions with help of this particular topology. Now, in this topology, you can see there's an HQ router, there's a headquarters. So this is a headquarters, guys. Okay. Now this headquarters will be having multiple routers, but like to represent, I've shown you one router over here, HQ router, and this HQ router to this HQ router, multiple zones are connected. Pune zone, Chennai zone, Noida zone. So these are the zonal routers, and to this zonal router, these branch routers are connected, right? Like to Pune router, this branch 1 Kothur is connected. Then here we have another branch, branch 2 as Wakad. We have branch 3, branch 4, and there will be multiple branches, right, in Pune. Of course, there will be multiple zones as well. Okay, we have Pune zone, Chennai zone, Noida zone, Bangalore zone, and multiple zones, Mumbai zone. Likely we will have multiple zones as well. So this is the network. Fine. Now I'll try to explain you how this frequent SPF update will happen. Right. Now let's say this particular link goes down. The link between Pune zone and Wakad branch. It goes down. What will happen? Now this router will send an SPF update to this router, and this router will send, that is the HQ router, and HQ router will send the SPF update to all the zonal routers. There will be other zonal routers also. To all the zonal routers also, it will send that update, right? Now this Chennai router will send the SPF update to this router, to this branch routers also it will send, right? Noida router will also send this update to all these routers. What is in this update? In this update, it is that Wakad branch, the link between Wakad branch and Pune zone is down. Now, if you think there's a branch router in Noida, sector 63. Now, this branch router in Noida, what is the significance of it getting this update that some branch in Pune is down? What is the significance? There's no such significance, right? Unnecessarily, this update has been sent to this branch router. Likely, other branch routers also. There's no significance that a branch in Chennai, Nunanbakkam branch in Chennai is getting the update. That branch router is getting the update that Wakad's branch router is down. There's no significance, right? So designing OSPF, guys, is so important. If you're not designing OSPF, then its biggest strength will become the weakness. Since this complete network is in OSPF domain, each and every router will have that same topology table. They will have the end-to-end visibility of the entire network, which can become a problem when we scale this OSPF domain or this OSPF network. Let's move forward. Let's move forward with the solution. Now, the problem statement is that frequent SPF update. A simple approach is to to fix this issue would be, don't send frequent SPF update. Send less SPF update. This will be a logical solution on this, right? Send less SPF update. Now, this could be achieved by a simple concept known as summarization. This could be achieved by a simple concept known as summarization. What do you mean by summarization? Now, those who have done Ccna may be aware of this summarization. Summarization is nothing but, rather than sending individual route in the update, we will send a summarized route. So, in summarization, we actually summarize these routes. Multiple routes will be summarized to one single route. So, whenever the router is sending any update, it will not send the individual routes, but it will send a summary route. I'll explain you again with this help of this particular diagram. So that is the reason I have introduced this particular topology, so that you guys can have a good understanding. So let's say this particular link have IP address 10.0. .0.0.0/24. This have like 10.0.1.0/24. This have 10.0.2.0/24, and this link have, let's say, 10.0.3.0/24. Okay. So if you summarize this routes, if you find the summary of this routes, of this individual routes, it will come as 10.0.0.0/22. So this is what summarization does. So it summarizes that this individual routes. So rather than sending, this particular router, the individual routes, this router, that is Pune zone router, will send a summary route of 10.0.0.0/22. Before summarization, individual routes were getting installed in the routing table of this HQ router. Now, rather than individual routes been getting installed, now this Pune zone router will send a summary. Will send a summary of this routes, and in the routing table of HQ router, rather than individual routes, a summary routes will be installed. Right. Now, even if, let's say, this branch, Walker branch goes down, okay, this router will get the update, will have that update, okay, that this Walker branch has gone down. Let's say it goes down. This router will have the update that 10.0.1.0/24 is down now, right, not reachable. But this update will not be sent to HQ router, because it is sending a summary route. When the update will be sent, when this whole network is down, means all the routers are down and that summary route itself is down, then only this Pune router will send an update. For the change in the individual routes, it will not send the update, because it is not sending the individual routes, it is sending a summary route. Now, this router will not get that update that Walker branch is down. So as all the other routers in the network will also not get update that the Walker branch is down. Earlier, what was happening, that this Nunan Bakkam branch was getting an update that Walker branch is down. There was no significance, right? So we have solved the problem by using summarization. Now we have summarized where? We have summarized on Pune zone router. Pune zone is summarizing the routes. But hey guys, there is another twist. The twist is that since we are doing summarization can lead to some problem. Okay. Of course, summarization has solved this problem of frequent SPF update, but this summarization can lead to a problem of lack of visibility issue. Now, what do you mean by lack of visibility issue? I'll try to explain. Now, let's say when we are saying that this Walker branch is gone down, HQ router is not aware of this branch is gone down, right? Now the problem is that here in this network is our network admin is present in HQ. There is there's a network team, there's a network admin which is present in HQ. Now this HQ network team or this router is not aware that this branch router has gone down. So that will be an issue, right? Now because he's not down, it will remain down. Nobody will work on it, right? This router has gone down, this link has gone down, and this guy over here is not aware of that. Nothing will happen, right? It will remain down because nobody is going to resolve that issue. So this network admin who is sitting over this HQ router should be aware that the Wakad branch is down. So it should be aware that the Wakad branch has gone down. This particular guy must be aware. So this is creating lack of visibility, right? Because he's not aware. That network admin is not aware. So how can we solve this problem of lack of visibility also? So we need to find some solution, right? That there should be no frequent OSPF updates, okay, and also there should be no lack of visibility. So solving these two problems together, one concept or just the solution on this is creating areas, and within areas we'll do no summarization. So there are two things, that for this huge network we have to divide this huge network into smaller areas, and within area we will do no summarization. Okay, summarization will be only done on ABR. So we see that there are two issues. One, frequent OSPF update, and second, lack of visibility. So to solve this problem, we have this solution, that is creating area. Okay, I'll repeat again. The huge network will be divided into smaller areas. Within area, no summarization. Summarization will be done only on border router, on the area border router, which are ABR. I'll also explain you in detail what is ABR. So let's take let's say this example. So guys, I'll try to explain you this concept of area using this topology. So we have this topology. Okay, now what we'll do is that our headquarters, okay, this headquarters will put it in area 0. This Pune zone, we will put it in some area which is non-zero. So this will be in area 1. Chennai zone will be, let's say, in area 2. Noida, let's say Noida will be in some other area. Let's say area 3. Likely we will be having other areas also, like area 4 for other zone. There will be some other zone, let's say in Mumbai. So it will be in area 5 and so on. Fine. So what area concept says that divide your huge network into areas, and within area no summarization. So there will be no summarization within area. Here no summarization. So this router is not going to do any, will not do any summarization, Even this router is not going to do any summarization. This router is not going to do any summarization. The summarization will be done only on the border router. Now what is border router? Let's say this is a router, okay. Now this is a router which will have one leg, I'll say, or link in area 1, and of course it will be having some internal routers connected over here, and those will be in area 0. So this is known as a border router, which is on the border of two areas. Okay, so this router, HQ router, will be in area, will have some link in area 0 also, and with some link in area 1 also. Okay, it will also have some link in area 2. It will also have some link in area 3. So such router is known as ABR, that is area border router. And this area border router will only do summarization. No summarization within area, but Summarization will be done only by ABR router. Guys, do remember this. Now, when I say it will do summarization, that means this router is going to send a summary to all the routes. For this particular routes that we saw 10.0.0.22, this particular summary route will be sent by HQ router to all the other routers rather than sending the individual routes. So in this HQ routers, I will have the individual routes /24, okay, 01 or 0/24. So I will be having the individual routes. So even if this Walker branch goes down, this network admin will come to know that Walker branch has gone down. So the problem of lack of visibility will be solved in this manner. And of course, there will be not frequent SPF updates, so there will be less SPF updates. So these are the two issues which can be solved by this area. So I have mentioned this point over here that of course, guys, this area 0 is known as the backbone area. Okay, so this area 0 is nothing but the backbone area. And all these other areas will call it as non-backbone areas. All the other areas will be non-backbone areas. So that is what I have mentioned over here, that area 0 and area non-zero. Area 0 is nothing but the area which is like act as a central exchange where all the non-backbone areas must connect, and of course non-backbone areas like gets connected to the backbone area. So let's say if this particular area 1 wants to exchange some route with area 2, it have to exchange through area 0. So the design will be like this. Like there will be always some area 0 and all the other areas will be connected to it. Area 1, area 2, area 3 and so on. So if area 1 wants to exchange some routes with area 2, it have to exchange through area 1 only, area 0. If area 1 wants to exchange some route with area 2, it have to exchange through area 0. Okay, two non-backbone areas cannot communicate with each other directly. They have to communicate through area 0 only. So this is OSPF area, rules in OSPF area. A lot of things we'll study when we will do configurational stuff, and you get better understanding, of course. So this area 0, that is the backbone area routers. Now this routers must be robust. So what do you mean by robust? So this routers are meant to handle this link state, huge link state database. Okay, they will have to do SPF calculations, also more SPF calculations. So this routers needs to be robust. They should have high speed interfaces, 10 gig interfaces, or maybe higher also, 100 gig interfaces also in enterprise network, depending upon the size of the network, right? The hardware should be redundant. Okay, it should have dual power supply, those routers. They should have high availabilities, like dual CPU and that kind of things. So that kind of things they should have. There should be stable software. The software should be stable. It should not be buggy software. The software should be stable, whichever software is currently running on those backbone routers. The links should be reliable. So there should be you can't have the links which are continuously flapping in backbone area. No, you can't have those links. So the links should be reliable. They should be they should have redundant part. I've wrote here that it should be fiber links, because of many advantage for fiber. So this is what the area concept is. So in this video, guys, we saw that a lot of stuff. We saw that there are two like the biggest strength of OSPF, the superpower of OSPF is that it have end-to-end visibility of the entire network. The convergence is fast, but this two superpowers of OSPF can become its weakness because in large network, in huge networks, there's an issue of frequent SPF updates. We saw frequent SPF updates, and this frequent SPF updates can cause multiple issues like high CPU utilization, high bandwidth utilization, etc. And because of this the frequent SPF updates, we saw a solution to that, that is summarization. But again, this summarization is leading to a problem of lack of visibility. Okay, this also we saw. So a solution to solve all these issues is creating area in OSPF domain. So we saw what are the characteristics of area, that areas, huge network, we divide into areas. Within area, we don't do summarization. Summarization is always done on ABR. So these are the 3 golden rules, you can remember for area in OSPF. So guys, that's it. This was a bit a lengthier video than my usual videos, but yes, this concept is also a very important concept. Whoever is studying OSPF, they should be aware of this concept. So guys, if you wanted to contact me, you can of course reach to me via from WhatsApp. You can reach me on this particular number. You can mail me on this email address, networkengineerstuff@gmail.com. If you need any notes or if you need any help, I can of course try to help you, and I do respond on this particular emails on this particular email address. Of course, you can visit my blog. I have a blog, a very good blog, networkengineerstuff.blogspot.com. Of course, you can follow me on Instagram, and there on Instagram, and you can of course have to, guys, I'll say must subscribe to my channel, Network Engineer Stuff. So guys, if you really like this video, please do share this video with your friends, colleagues, and please hit that like button. Please subscribe to my channel, Network Engineer Stuff. I'll stop here. Bye. Have a nice day. Thank you.